we want to find out if the series is convergent or divergent. So we're going to use the integral test because we know three things about this series. We know that it's continuous, we know that it's always positive, and we know that it's decreasing because that denominator is going to have larger and larger terms. So this is definitely satisfying all those conditions, and you can put that into a graph if you don't believe. So now we have to take the integral of this, and the integral, if that diverges, then our series diverges. If it converges, then our series converges. So that's the integral test. We have 1 over x, root of natural log of x. We're integrating with respect to x. And if you remember how to solve this, we take u equals natural log of x, du equals 1 over x dx. Now we can make that substitution when x dx is this thing, so we get du, and we're left with this, which is u to the power of negative 1/2. U to the power of negative 1/2, which when we apply the integral, this is going to give us to the power of 1/2, because we add 1 and then divide by that, so we get 2u to the 1/2. We make our back substitution. This is 2 natural log of x to the 1/2, which is the square root of the natural log of x. So that's what we have, and we are, remember with this though, we're not just adding plus c, we are integrating from 2 to infinity. So this was from 2 to infinity, and we can't do infinity directly, so this was t, and then we do limit as t approaches infinity. And here we're still doing that. We're doing limit as t approaches infinity, and this is 2, because that's where the series starts, and we go to t, because we can't directly work with infinity. So now we have our two pieces, our upper part and then our lower part being subtracted. So the upper part is going to look like this. We make our t into our x, and then we subtract 2 root natural log of 2. And we're taking the limit as t approaches infinity. So now we can plug our infinity into here, and this is going to be infinity, and that's just a constant, it's just a number. Infinity minus some number is just infinity, so this diverges. Our integral diverges, which means that this also diverges. If it had converged, that means that this also converges, but not necessarily to whatever integral the integral converges to. This could converge to some other thing. But yeah, in this case, because we got infinity, this diverges by the integral test.